This tutorial is on solving problems involving friction. So a crate at rest on the floor has a horizontal force of 25 newtons applied as shown. The crate weighs 80 newtons. Its mass is 8.16 kilograms, so the weight is already calculated for you. The coefficient of static friction between the crate and the floor is 0.4 and the coefficient of kinetic friction is 0.2. What happens to the crate as a result of the applied force? So let's draw a free body diagram. So the first force we want to identify is the force of gravity, which acts downwards, represented by Fg, and you calculate it as the mass times acceleration due to gravity, and it's already calculated for you as 80 newtons. And because the crate is on a surface, it pushes down on the surface pushes it back up, and that is what we identify as the normal force. And we know that the crate is not going to have any acceleration in the vertical direction. That means these two forces must cancel each other out. So the normal force must match the force of gravity. So therefore, we know that its value is going to be 80 newtons. So you are applying a force of 25 newtons. So let's call that as the applied force, which is 25 newtons. When you try to move an object, friction comes into play in preventing it from moving. So the friction now, we have to determine how much it is. So let's call this as F for now, and then we can determine whether it is static or kinetic based on the applied force. So we know that the minimum force required to move an object is the limiting friction, which is Fs max, and can be calculated as mu s times Fm. It's given that the coefficient of static friction is 0.4, so 0.4 times, and we calculated the normal force is 80, so 0.4 times 80, and that is equal to 32 newtons. So you need a minimum of 32 newtons in order to move this object. So if you apply 25 newtons, it is not going to move. So since your applied is less than Fs max, the object does not move. But if the object doesn't move, what is the friction in the system? Well, if it doesn't move, that means it's in equilibrium. So that means the friction is just enough to cancel the applied force. And since it is not moving, you have to label this as static friction. So Fs is just 25 newtons. Let's take the problem a step further. So what if I now apply 32 newtons and get the object to move? Will it move with a constant velocity or will it accelerate? So let's redraw the free body diagram. So we have our Fg as 80 newtons and we have our Fn as 80 newtons as well. And our applied force now is 32. So the object is now started moving. And you know, once it is moving, your friction is no longer going to stay the same. It now becomes your kinetic friction, which we have to recalculate. So Fk is mu k times Fn. And if you look at the problem, it says the coefficient of kinetic friction is 0.2. So your kinetic friction Fk is 0.2 times 80, which is going to be 16 newtons. So that means you are applying a force of 32 while the friction is only 16. So let's make our free body diagram reflect that by drawing a arrow that's twice as long as this one to indicate that this is 32 newtons and this is 16 newtons. So this object is no longer in equilibrium. It has a net force and therefore will experience an acceleration. So let's calculate the net force. Net just means total. Since these two forces have cancelled each other out, we don't have to worry about them. So there is a 32 Newton force to the right and a 16 Newton opposing force to the left. So your net force is F applied minus Fk, which is 32 minus 16, which is equal to 16 newtons. So this is your net force. And once you know the net force, you can find the acceleration by using the formula F net equals ma. So 16 equals, the mass of the object is given to us as 8.16 kilograms. So 16 equals 8.16 times A. So you can calculate acceleration as 16 divided by 8.16 meters per second squared, whatever that is. So to recap, remember that you always have to check whether the applied force has overcome the maximum static friction in order to make the object move. And once the object moves, you have to recalculate the kinetic friction and evaluate the net force in order to find the acceleration.